Hey everybody, welcome to another GRE Prep Hour. I'm your host, Tyler, and I am an instructor and tutor with Manhattan Prep. And I love teaching these prep hours because it's a fun hour-long session where I get to kind of go deep into a topic that I don't usually get to cover a whole lot during our course or my tutoring sessions. And today, it's going to be all about data interpretation, which on the latest GRE is only going to appear in your first quant section, but there are going to be 3 questions that are all data interpretation. So it's not something you can ignore. You want to make sure you know what you're doing for those 3 questions. Um, and this session, it's happening live in a Zoom room right now. You might be watching it as a recording on YouTube later, but hello, whether you're here live or, in the future watching asynchronously. If you're here live right now, what I want you to do is in the chat box, tell me what city or where on earth you are located right now. I am joining you all from San Francisco, California. It's a lovely day out there. Let's see where everyone else is checking in from. Atlanta, where the players play. Austin, Texas. Big fan of Torchy's tacos. We got some more Texans in the house. Canada's here, Florida's here, Chicago's here. We got like all the US time zones represented. Maybe not Mountain. Maybe we didn't do that one yet, but it's a pretty good spread nonetheless. All right, well, welcome everyone. We're going to go ahead and start talking about data interpretation now. And first point I want to say here is that when it comes to DI, data interpretation, DI for short, it's always drawn to scale. And that's important because compared to geometry, right? If you're looking at a regular circle on the GRE, that is often going to be drawn in a deceiving way, and you can't really trust your eyes. But whenever it's a data interpretation problem set, all those charts, figures, graphs, all of it is going to be drawn to the exact scale, which means, this wedge of apples right here, that is actually 19% of the circle's area. And this wedge of tomatoes over here, that is actually 13% of the circle's area. So you do get things drawn accurately when it comes to data interpretation. And for reference, the other pieces that are drawn to scale that you'll see on the GRE, anytime you have coordinate geometry, like if there's an X and Y axis drawn, that is going to be to scale, as well as any number lines. And also, if a problem ever writes in text, the figure is drawn to scale, you can trust that. But otherwise, if it's geometry, don't trust your eyes. You want to play with the interpretation of the shape. Like if they tell you that something is a rectangle, recognize that could also be a square, right? Like it doesn't have to be a non-regular shape. So if you don't know that about the GRE, look it up. There's lots of videos out there about geometry and how deceptive those figures can be, but not the case on data interpretation. You do get to trust your eyes here. So let's go ahead and take a look at a question based upon this diagram. If you're here live, what I want you to do is chat your answer to me using that chat box, and I'll give you a few minutes to look at it. Here you go. All right, it's been about 3 minutes, so we'll take a look at the solution here. And one piece of advice I have for the entire quant section, not even just data interpretation specifically, but every quant problem, always peek at the answers before you begin your solution. Because what I'll see here is there is a good amount of spread in the answer choices. They run from 14 degrees at minimum all the way up to 55 degrees at maximum. And when that's the case, when things are spread out like that, that indicates that you can estimate and be okay. So if you calculated the right answer by, doing some math here, there's nothing wrong with that, but I think you're working too hard, because the simplest solution I can make here is we're going to be looking at this lettuce wedge right here. And this line on the right is already, kind of like perfectly horizontal. So just kind of eyeballing it, I'm sorry, I meant perfectly vertical right there. And then if I kind of add a perfectly horizontal line in my mind, I can tell that if we had something that was 45 degrees, perfectly splitting those blue lines, I know this pink wedge is under 45 degrees. So off the bat, I know choice D, choice E, those are too big. And looking at what remains, 14, 20, and 32, this angle is not going to get so small as to be 14 or 20. I can just kind of eyeball it and tell that lettuce wedge up there, it's around 30 degrees. So without doing any math at all, I can just sort of logic my way to the answer. Now, you always want to check the answer choices to see whether that's feasible. Because if I had some answer choices that look like this, now everything is a bit more clustered together. And I'm not going to be able to just kind of eyeball it and eliminate. I might be able to still get rid of the extremes. Like I don't think it's going to be 40 degrees or 24 degrees, but debating between these three is going to be a little bit tougher. And you could use a calculator here, but I'm always a little skeptical of using a calculator, except in choices where the math is really rough, right? If I'm multiplying two 3-digit numbers together, or, anything where there's like 5 or more digits involved that I'm multiplying or dividing, yeah, I'll use a calculator there. But remember that everything is drawn to scale. And I'm trying to find the angle measurement of this wedge that is 9% of the circle. And 9% is about 10%. So I'm just saying, what's 10% of 360 degrees? That's going to be 36. So my answer has to be a little bit under 36. I know D is out. And if you're still not sure between 28 and 32, just think what's 1% of 360. And you're just going to move that decimal point in one more place. So to find 9%, you're just going to subtract those two. And you'll get exactly 32.4, which is closest to choice C. So kind of two different routes depending on what the answer choices look like. And that's why you always need to look at the answers before you start solving, because that's going to inform what kind of solution options are available to you. And whenever you can, estimating is going to be faster and easier than going the precise route. So take that route when it's available. Okay, let's do another problem on the same data set. Here you go. You have about 3 minutes. All right, let's also take a look at the solution here. And the more straightforward way to do this, that's a little bit slow, but I'm not going to knock you if you did it, is to sum up those 3%. Right, we're combining tomatoes, apples, and bananas. So 13, 19, and 14. You'll see that's 46%, and then you can take 46% out of this total right here. And that will get you correct answer A. But that's a little bit overkill. There is an easier solution here. Involve just looking at those answer choices first. And seeing I go from a little over 2,000 all the way up to 2,500. And then if you look at the circle, tomatoes, apples, bananas, like this line right here, it almost cuts the circle in half. It's not quite exactly 50%. It's more like 52%, but it's almost half. And we are excluding this carrot wedge right here. So it's going to be something more like, I don't know, 46% of the circle. And what you can quickly realize using a bit of number sense is like, okay, this entire half of the circle would be half of that 4,440. So, that number would be around 2,220. And we have even less than that, right? We don't have a full half. We're missing the carrot chunk. So it's got to be underneath 2,220. And only A is a viable answer. So always look at those answer choices, know the data you're working with, and if it's a circle chart, like breaking it into a half or a quarter, that's often going to reveal some helpful information here. All right, so let's move on from pie graphs. We're going to look at a kind of chart the GRE really loves, one that I think is less useful in real life, but the GRE loves it because a lot of people are going to misread it. This right here is called a segmented bar graph. And what you need to know about these is every bar does not reach all the way down to 0. For example, if I wanted to know the amount of Happy Jacks sold at store 4, I have to look at the lines where that individual bar begins and ends, right? I don't want to extend that all the way down to 0. It refers specifically to that start point and that end point right there. And if I look at those numbers, it's going to be something like we start at 25 and we end at about 33. So that whole chunk right there, that represents 8 units sold. So segmented bar graph, don't extend it down to 0. You have to look at the individual start and end points. And now that you know how to read this, I'll give you a few minutes to try out this first question. So there's a couple ways to go about this. I'm going to show you my preferred method. For this question, we are only looking at brand smart cereals, and we're going to be looking at store 2 and store 4. So just these two, and the brand smart, it's this vertical line chunk. And I'm looking for the ratio of that store 2 amount over store 4. Now, before you grab your pencil and start writing a bunch of math out, recognize that I can use my eyes because it's drawn to scale. Essentially, I'm just trying to find the ratio of this smaller green chunk from store 2 over this bigger green chunk from store 4. And just visually, what it looks like to me is a little more than, call it like a 1-to-2 ratio. But if I look down at my answer choices, store 2 is not the bigger one, so it couldn't be D or E. I got to have a smaller number on top. And between A, B, and C, only one of these is around that 1/2 that I'm benchmarking with my eyes, right? It doesn't go all the way up to 5/6. It doesn't get close to 3/4. This one is safely 4/7. A little more than 1/2, but that's what my eyes tell me just looking at it. And again, when it's multiple choice, when you have those options, always check them out, see what the range looks like. When you notice a spread like this, you're not going to have to do any more than just using your eyes. Now, if this had been a data interpretation question, or I'm sorry, not data interpretation. These are all data interpretation. If this had been a numeric entry question, where they give you 2 boxes and they say enter your numerator and denominator separately, then I'm going to need that precision. And I will have to go through and, mark off, okay, so this one starts at like 46 and it goes all the way up to 66. So I'm looking at a total of 20 units right there. That's where you got to do that kind of thinking. But otherwise, your eyes are going to get you really far in data interpretation. One thing I like to say about the GRE in general is that on quant, it's not a math test, right? They call it a quantitative reasoning test. As such, all the math over here, it's testing how much you can use logic and your eyes and alternative solutions just as much, if not more so, than your ability to actually like apply algebra and crunch numbers. So whenever you can, I'm going to encourage you, use alternative strategies. If you can get an answer by picking numbers or looking at the answer choices and using logic, that's typically going to be easier and faster than doing it like the hardcore mathematical way that your 8th grade math teacher would have taught you to do it. Let's check out another problem on this same chart. Here you go. So in this problem, we are looking at X at store 3. So Happy Jacks, that amount right there. And what's happening is it's going to double while the other amounts remain the same. So my visual trick here is I like to take that chunk of Happy Jacks, and I'm just going to imagine there was another chunk of Happy Jacks on the opposite side of the bar. So I kind of double it in that way. So not only did the Happy Jacks amount double, but the total amount of cereals moved by store 3, that got a bit bigger as well. And granted, I have the luxury of drawing and annotating on my screen. You're not going to be able to do that during the test. But what you can do is take your pen and kind of like hold it up to the screen and then just kind of mark off with your thumb, whatever amount that Happy Jacks is, and then kind of move it and let that be a visual reference for you, just using your pen as a ruler almost. And now I'm just asking, okay, those 2 green chunks out of the total amount of cereal sold by store 3, how much is that? It's definitely not as high as 50%, nor is it as low as 10%. Between B, C, and D, as you get better at estimating, it'll become clearer what this actually is. But it's not going to be low as 20%, right? It's not just 1/5 of what we got there. The green is a bit more. Nor is it 40%, right? Nor is it 2/5. What we're looking at is a solid 30%, 3/10. Sometimes it helps for me to convert from a percent to a fraction or vice versa. Everyone's a little bit different. If you prefer to think of fractions or decimals or percents, just kind of convert it to whatever's the most comfortable. But yeah, for me, it's looking pretty clear that those green chunks, it's about 3/10 of that entire bar there. Again, if this were like numeric entry, enter the percent into the box, I can't do something like that. I'm going to need to be precise. And that's where you got to think about the endpoints. So we'd say something like it goes from about 22 to an endpoint of about 32. So there's 10 units in total, plus another 10 units because I doubled it. And that'll take us from, I don't know, 57 units moved to a total of 67 right there. So you're just doing 20 over 67. And that is about 30%. But when you got answer choices, you're not going to need to do that because you can just look and estimate most of the time. Okay, we got one more on this same chart here. This next one is going to be a select all. So there are potentially multiple correct answer choices, but there will be at least one correct answer. So take a look and chat me your answer when you're ready. Beginning with choice A. What do we know about the sales and the revenue according to this graph? Well, we know that what we're looking at, we've got 3 cereals, 4 stores, and the sales numbers for boxes. But that's not enough to determine the revenue, right? We don't want to make the assumption that every box is being sold for the same amount at every single store. And good advice for the entire GRE, whether it's quant or verbal, don't make assumptions. Even if in the real world you think it would be totally logical for these 4 stores to be selling them at the same price, without the information, I don't want to assume that. So we have no information about the prices and we can't make an assumption about revenue. So that is not necessarily safe to infer. And A is eliminated. On to B. Of the 3 cereals, store 2 sold a higher percentage of Crispios compared to store 4. So I'm looking at Crispios, and it's a percentage. So I'm kind of taking that green chunk out of the whole bar, and I'm doing something similar in store 4, looking at that green chunk out of its entire sales. Does store 2 have a higher percentage of Crispios? And the answer is going to be yes, because it has a higher number of boxes sold out of fewer total boxes. So if it's a higher absolute number out of fewer total, that will always lead to a higher percentage. And I didn't have to calculate anything there. It was just a matter of looking and using logic. I can do something similar with C. There's a way to get this without having to do a calculation, but I'm going to need to visualize very clearly. So they're saying stores 2, 3, and 4. Do they all work out to an average greater than 25 for Crispios? So that initial diagonally slashed bar. And recognize store 4. That one is exactly at 25. And store 2 is exactly 5 above at 30. So if store 3 were exactly 5 below at 20, everything would average out to 25. Because I have 25 and then 5 above at 30 and 5 below at 20. That makes an average of exactly 25. But check it out. Not only is store 3 not 20, it's 2 more than 20. So if 20 would have given me an average of exactly 25, when I'm sitting at 22 right here, that's going to push the overall average greater than 25. So C is also correct. Okay, moving on to another data set. We haven't yet seen a line graph, so let's try one of those. So visually, we are looking just at January and June. And we want to know how much did that purple line increase by in order to end up at that blue bar over there. And I know just visually, like we are adding more than about 25% to that. Between C and D, I think I'm going to have to be a little more precise, but visually, we're not getting close to 40%, but it's somewhere, hovering around a quarter to a third. And something like that, I may not always be able to visualize. And that's where it's important to know the percent change formula. So estimation will get you far here. A 50-50 is never a bad situation to be in. But to actually get the right answer, I think I might go ahead and do that calculation. So I subtract, starting with my new value where I end up, 5143, subtract the old value where I started, and then divide everything again by that old value. And that's going to get you 1253 divided by 3890, and that'll be 32%. So the point of this lesson is not like use your eyes and only your eyes for every single problem. It's let your eyes take you as far as they can. You're often going to be able to make some eliminations based on visualizations alone. But when you need that precision, you want to be comfortable and know how to handle the math as well. Here is a question type I see a lot on the GRE. It's something we haven't talked about yet. So let's take a look. Because I see this question type show up so frequently, I've developed my own kind of special formula for it. I call it correcting the average. The way this works is you can calculate the new correct average by taking the old wrong average and then adding whatever the change that you're dealing with is divided by the total number of terms. So the change in this case is the old incorrect amount is 3890, and that needs to be raised to 4072. So applying my formula here, it's going to look something like this because my number of terms are just the 12 months of the year that are represented in that chart. So I don't have to redo some massive sum. I'm just looking purely at the number that changed. So 4072 minus 3890, that's going to be 182. And that divided by 12 is about 15. So my new average is going to increase by about 15, and that puts you at a 4,740. And that's about as simple as I can make this one. I haven't yet found a quick visual solution to this. I think just memorizing this correct the average formula is the way to go. Take a look. Okay, so as mentioned, this one is very difficult. And to get the ball rolling here, I'll ask you to consider the following question. How is this data arranged? Because US, Japan, Germany, China, UK, it's not alphabetical. What is the key metric we're using to arrange everything? And everything in both the chart and the accompanying table, it's sorted by this column here. GDP from biggest to smallest. So if I look to Canada, I'm trying to find countries that have a smaller total debt than Canada. So which of these countries have a debt smaller than, what is this, like 65% up to 51? But here's the key. I'm not going to make that calculation yet. I don't care what 65% is of 1251 until later. Because right now, logically, I know the following. That all of these countries below Canada, they have a percent of the debt as a percentage of GDP. That's all lower than Canada. And likewise, their total GDP is all lower than Canada. So all of those, they all qualify because they have smaller percentages of smaller total GDP. So count them up and we know we've got at least 1, 2, 3, 4, 5, 6, 7. We've got 7 in that bunch so far. Now looking at the others. I know Italy, that's got a huge percent of a bigger value. So that one's going to be bigger than Canada. So I'm not going to count that one. France has pretty much the exact same percentage, but out of a larger total GDP. So that's going to be bigger than Canada. And same thing for Germany, US, and Japan. Those all have percentages either equal to or, in the ballpark or greater than Canada, but they have some huge total GDPs. So that's all going to be bigger than Canada. Really, there's only 2 in here that I have to be concerned with. China and the UK, I can't just eyeball those. I got to be a little more precise. Now, UK, this one is probably like 45% out of 2,345. And doing some rough napkin math, I'm taking about half of 2,300, call that like 1,100-ish. And if Canada is about 2/3 of 1,200, I know UK, that one's bigger as well. But China over here, it's a pretty small percent. We're looking at like 18% out of 2,668. So that is going to be, call it less than 500, just doing some rough ballparking. Versus Canada, if it's 2/3 of 1,200, be more like 800 over here. And again, I'm resisting that urge to get out the calculator and know the exact value. Things are typically not going to be that close on the GRE. You're going to have enough wiggle room here that the back of the napkin math is okay. So China, we found another one. So it's the 7 countries below Canada plus China above. That gives us a total of 8. So our answer is A. And the ultimate takeaway I want you to grab from this problem is when you have these setups that are like, how many categories satisfy condition X? What you want to do is visualize most and then calculate a couple. You should be able to get most of the work done just by using logic. And then you don't want to calculate every single one. There should only be one or two where you got to get a little more precise. Because if you're trying to do this to all 8, it's going to be a long, long solution. It's going to take you like 6+ minutes. You can't do this on this test. So use your eyes as far as you can go. And then at most, you'll be testing like 2 or 3 more precisely. All right, so that's how it's done. We're going to start wrapping up here. So a few main takeaways. At the start of every problem, you should look at the answer choices. All over the quant section, regardless of whether it's data interpretation or a regular multiple choice question or yeah, anything where there's answer options, check them out. And if they are spread, that opens the door to estimation. You've got that option at your disposal. If the answers are clustered tight around some central number, that indicates you're going to need to use more precision. And certainly if it's a numeric entry problem, right? If there's no answer choices at all, you got to be precise in that instance as well. And don't forget that data interpretation is drawn to scale. Unlike geometry, where the diagrams are often deliberately deceiving, anything in a data interpretation question is exactly to scale, so you can use your eyes and get away with a lot. And while you're using your eyes, it's going to be helpful to benchmark values like 50% or 10%, or if it's a pie chart, looking at 90-degree angles and 45-degree angles, get those visual references. And if at any point you find yourself doing a huge calculation, you got to pump the brakes and ask yourself if there is an easier way. On that problem we just looked at, the really tough one with Canada, if it's how many categories satisfy some condition, you're going to be able to visualize most of what those are. And then you should only need to do the hardcore calculations on a couple. And you'll see this other one down here. This is most often the case for line graphs. If they're asking you about the average change for a set number of periods, don't calculate the change for every single period and then try and average all those. Instead, just look at 2 values, the start point and the end point, and then divide that by the number of change periods in between. All right, so that was our lesson on data interpretation. Those were some of my favorite tricks. I hope you enjoyed. And if you'd like to come check out these at some point in the future, check out the URL that's on screen. If you're watching this on YouTube, there should be a link in the description as well. And if you're in Zoom with me right now, I'm going to go ahead and paste that in. And in addition to our free prep hours, we also open up session 1 of our 9-class course up to the public. So if you want to check out a longer 3-hour lesson, you're welcome to enroll for that. And then if you like it a lot, you can sign up for the full course. So once again, it's great to have you all here. Hope you learned something. Hope you enjoyed it. And yeah, hope to see you again at some point in the future, whether it's another free prep hour or a trial class. Take care.